Alright, I'm going to teach you a little bit about GeoGebra. It's a powerful, awesome math program. You could use it web-based so you don't even have to download it. So first go to geogebra.org, geogebra.org, and you just click on Start GeoGebra. And for this video, I'm going to go in the spreadsheet, but we'll talk a little bit more about algebra. Probably those are the only two we'll stick with. So I'm going to look at what page is that? Page 55 in the guided worksheets, number 1. It looks like, I don't know if it was an accident or not, but they already had completed it for you. Maybe it was meant to be an example. So let's look at this minutes and this cost. We have 0, 100, 200, all the way down to 500. And the cost, they said, is 5 cents per minute. Well, if we do 5 cents multiplied by that, let's see, what do I type? A2, 5 star 2.05 star A3, right? 5 cents multiplied by this one. I don't know if there's an autofill feature or not. I haven't played with it that much, but to save some time, I'm just gonna fill in the rest. It's not the important part for this one. I think Excel, can do that well enough on its own. Now the cool thing is though, so I built this data. I'm gonna highlight it. We click up here to a 2-variable regression analysis. We'll get to more of that a little later. But basically, we have an X and we have a Y value, right? The minutes is the X and the cost is the Y. That's 2 variables. Click on that, and it graphs it for us. Pretty awesome. One thing to point out as well, now, we don't really need statistics for this one, but we've done a lot of statistics in Excel using mean, median, mode, and all that. So it gives us the mean of the X, the mean of the Y, standard deviation of the X, standard deviation of the Y. This R is something that's new. The R is going to be between -1 and 1, and that tells us the strength of how well a line would fit on this data. So being a perfect 1, that means a line would go straight through this data. We have a linear function, and that it's a positive slope, which we can see. All right. More importantly, down here we have this regression model. If we hit linear, it tells us the equation of this line, 0.05x. So it's y equals 0.05x. I don't know why they don't have the y equals there. I'm sure there's some settings we could play with, but that is awesome. Now, one thing to point out, the x and y axes aren't necessarily aligned, right? Like this shows 0 here and 0 here. So realistically, the x-axis is here and the y-axis is here. The algebra side of that, if I open this up and did that same thing over here, this is in fact, aligned where the origin should be. But no big deal. There's a few other settings in here you could play with. One thing I want to point out is when you go to save it, you click here. You can save it, and then when I ask you to upload a graph, that's how you would do it. Or you can export as a GeoGebra file or a PNG. Sometimes these are a little tricky though, and it's hard to find the graphs. So play around with that. What else was the cool thing I wanted to show you? Let's see. Oh, right here. Okay, so for this graph, I have automatic dimensions, so it determines how it should look on here, which usually that will suffice. But we could play around with this and pick where we want x to be, right? Like say I just want it to start at 0 to 500 because that's all our data is, and so forth. The x step tells it how what's the intervals that it will mark the x-axis? So since we're only going by 100, why not go, 100? Y-min, we went from 0 to 25. Oops. 0 to 25. The y step, we were counting by 5, so might as well leave that at 5. Okay, and then click off of that to hide it. And there's our line. So pretty cool. You're going to need to find equations and using data, and sometimes they won't be perfect, and that's what this regression model is. Just to show you really quick, let's say it changes 10 to 10.5. Right, so this one's barely missing. Maybe we'll change. Oh. See, I knew you could click the cell. I don't know what was happening earlier. And let's change this one to like 19.5, for instance. Okay. Now when I go into that statistics, you'll notice R isn't 1.95, which means it's pretty close to fitting all of our data. And these other ones we won't be using in the course, but it is cool that they do have. Okay, so linear. Let's go ahead and hide this. Maybe zoom out just a little. I never like going exactly where we did. I always go a little extra because then we get to see really what's happening. But anyways, have fun playing around with it. I hope it helps. Get rid of that. Now you can see, where our data falls on here. And I didn't mean 29.5. That throws it way off. I meant 19.5. There. That way they're just, slightly off. Now if we look at our statistics, 0.9995, right? It's really close to being perfectly linear and fitting this data.